Now I'll show you about the Bessel filter, which is this blue line, and in comparison to the other two filters, Chebyshev and Butterworth, this Bessel filter has an advantage of linear slope, which you can see in this dotted line, which is indicating that it is suitable for audio applications and speech applications. Now, in contrast, as a trade-off, Bessel filter has a trade-off that it is having a slower roll-off in comparison to Butterworth and Chebyshev filter. Now we will implement this Bessel filter in this hardware. Now this is the circuit we have chosen for Bessel filter, which is also silent key fourth order filter. This is a low pass having cutoff of 7K. This is Butterworth. This is high pass of having cutoff of 2 kHz. Now I will sweep the frequency in this. Like the first one is the input to the Bessel filter, and second one is the output of the Bessel filter. So as I increase the frequency, the output of the Bessel filter increases amplitude. So we can see it properly functions, and as I increase beyond 7K, the frequency is decreasing, which means it's a band pass filter. So if we go to the FRA and rerun this, so as we can see, this is the output frequency response analysis of the Bessel filter. The roll-off is little bit slower than Butterworth and Chebyshev filters, but we can also see a little bit smoother than Chebyshev thing, and also a linear phase here. This is 7 at 7K. This is 7K, which we see at 3 dB, and at 2K we have a minus 3 dB again. Yeah, at 2.89 Hertz we have 3 dB. So if we input a square wave again into this filter and put a comparison frequency as 5 kHz, there are again same harmonics, 5 kHz, 15 kHz and 25 kHz and so on. But then due to the slower roll-off of the Bessel filter, this is not able to properly filter the square wave. So there are components of 15 kHz and other hertz, 25 kHz, and also interfering with this output. So this is the FFT, and this is the amplitude of the 5 kHz. This is the amplitude of 15 kHz. This is the amplitude of 25 kHz. So as we can see, there is not much significant difference between this and this. So it gets interfered into this output.